Hello, everybody, and thanks for joining me again today. I hope you had a lovely weekend. Let's transition to the code view. So last time I sort of started questioning whether I have all my types representing diagram or drakon diagram elements correct. And I've done a lot of thinking over the weekend, and I went through this or fragments of this paper a couple of times, and I have a slightly different idea for today. I thought I would be just continuing down the path of building up letters and words, but I'm just not getting the right vibe from that idea. Um, what I think makes most sense is this paragraph of the white paper describing visual letters and words. But for our application, I think what matters most is these two last paragraphs. One is describing what a skewer block is, and one is describing a terminator. So a skewer block is like a visual element of any drakon diagram that has one single exit and at the bottom and one single entrance at the top. Meanwhile, a terminator is a component that only has one exit and no entrance, like for example, title icon or title letter, and or else a terminator could be an element that has an entrance but no exit. So, for example, the end letter. And so I thought what would make sense for today's session is go even higher up the abstraction hierarchy, and instead of focusing on letters and words that can be put together, let's maybe focus on the more general concept of the foundational building blocks of any drakon diagram. And that, reading this paper to me, seems to be the skewer block and a terminator. So what I'm planning to do today is to create an issue. Terminator type, or implement terminator and skewer block. Should. All right, so we have the issue ready. I hope you have your nice cup of tea or coffee or whatever you choose, and let's get coding. Sorry, not this. So I'll most likely move these types around, but for now, I think this is good enough. I'll just place them here. Let's just call it block. And it could be either a terminator or so this is my terminology. A block can either be let's stay faithful to the white paper. They're using a term terminator and skewer block. Okay. So what I'm planning to do today is just to create a very basic list of these types so that we can maybe represent it visually using terminal. So we have the type. Well, maybe we should actually put it here in data types. It doesn't make a huge difference, but let's keep similar blocks together. Let's implement show. But not just yet. Oh, sorry. Oh, I need to start my Docker. I've just restarted my machine. Come on. Oh no, sorry, Docker was working. Perfect. Now, this builds. So for Terminator, we're not going to distinguish. Ignore. We're not going to distinguish yet between a title terminator or end terminator. It's just going to be plus and skewer block as a general shape. It's going to be the pipe operator. Okay, so now that we have show, oh sorry, that's not icon kind. So that works now. So in main, this main is very complex. So what I was thinking during the weekend is this main is very complex for what we're going to need in the short-term future. And just a reminder, I want to rethink how I represent my diagrams, both in text files like this and in types, in order to challenge once again how the layout engine is working. I'm not fully happy with it still, and I believe it will provide a pretty entertaining type of refactoring on my part. Um, so yes, if a new person was to be given this type of code, I think they would scratch their head for a long time before they figure it out how it's supposed to work. And I don't necessarily have that as a goal. I want the code to be pretty straightforward, or as straightforward as the circumstances allow. So, because this package is not used by anybody, it's not released anywhere, we have the luxury of just doing this. And providing a new main. So in our new main, we'll just have let's check Cabal. Hello, drakon. Perfect. So, all right. So as a test, let's go to our new main and let's define a function that will prepare a sample diagram for us. So if you look at the documentation, or at least I think that would make that is what makes sense. A diagram is really now fluent transition to this. A diagram really is a 1D list. So my intuition here was correct, but only accidentally. A diagram really is a 1D list of icons, but some of these icons are nested data structure where new letters and new words get injected into their valence points. You see these dots, these are valence points. We'll get to that, but there are, I'm saying this now, there are two types of operations on a drakon diagram that I can see. In order to build up a drakon diagram, you can either put together skewer blocks and terminators in a line, or you can insert words or letters into valence points. We'll get to all those rules a bit later, hopefully. These rules are defined near the end. Yeah, here. Description of drakon visual syntax. They're all defined here. And these rules, they dive straight into insertion, whereas what I feel we could benefit from a bit more is how to stack building blocks together. But it's fine. It's a seemingly short paper, but there is a lot of content to unpack and interpret. So let's go back to the code. What we need to do is import data types. but we're not interested in icon kind, but block. And here, this is going to be a constant. And it's going to be defined as so. Just two terminators. In our case, sorry. Should be like this. Oh, I think I'm doing something wrong with syntax. Oh. Okay, but we're showing the list. It's not too bad, but that's not how I wanted to show this. So before we proceed, so we're getting plus plus, which is correct. But what I wanted to do is not to show a list, but show items arranged in the vertical order, not in horizontal one, and without the list markings. But we can correct it very easily. We're building the weirdest diagram. So, perfect, yeah. The lights are vertical. And I want the whole arrangement to be vertical. Now, I believe if we organize elements like that using a terminal, it should be natural to take one step further and start fleshing out what a skewer block could be, what a terminator could be, and maybe start working on the insertion. All right. So now let's go back to data types. And I think this is as general as I can get. So a diagram is going to be a list of blocks. Oh yeah. So it's let's go very simple. So it's going to be a list of either terminator or a skewer block. How do you do this? Oh, so that's not data, that's a type. Oh, I don't have to do that. It's just a list of blocks. Perfect. All right. So now we can reduce this. Let's see if this builds. I think I am doing that. Oh, where T is not a synonym. And in our case, diagram is a synonym for a list of blocks. But let's see if this extension GHC suggested is good. Okay. Okay. Flexible as this is. Oh. I can't forget I still have the old code, so I can't just delete overloaded strings. Oh, and here is not a show. Sorry, here is not just an X, but a show X. What happens if I remove this? No. How about think I'm done with this type synonym. Let's delete this. Let's just create a algebraic data type. Check the syntax. Okay. Let's do new data then. Okay, this seems to be working. Oops. Oh yeah. This should be X. Oh, what am I doing? This is X. Perfect. Let's try to run this now. Now, here we're still dealing with a list of blocks. Instead, let's do start with a diagram. Sorry. Okay. This is what we wanted. This is what I wanted. So in that case, let's do a quick format. And I feel we can start building on top of this. Where Terminator is its own icon and skewer block in the future becomes its own icon. Let's see. Maybe we still have a minute today. Or maybe we don't need that. No. You know what? Thank you very much. How about we just give, instead of looking for exotic ASCII characters, we just give Terminator letter. For now, it's going to be a T. So the documentation says that icons 1, 2, 3 in figure 1, title, cyclic start and end are terminators. And drakon words 1 and 2 from figure 2, 1 or 2 are terminators. Okay, so let's implement this fully. It will be title or end. Perfect. Title with parameters. It's a cyclic start with parameters. Do I need to define this for the terminator? Hopefully not. Let's see. Oops, that didn't format. You know what? Let's kick this all out to main. This doesn't make sense. Pattern matches are not exhaustive. Here, okay. Would this work? It's not showing. Can we just do this? Not really. Oh, I see. Did I delete this? Okay, now I need to get this T to work. Just show maybe. not sure if I'm doing it right, but it might work. This is not exactly what we're looking for, though. Excuse me for a minute. All right, I'm back. So I'm not sure how to do this and if it's even possible. So what I'm going to do is to, instead of using parameterless constructors, I'm not sure if this is how it's called. Let's just give each terminator a name. Let's just check if this is how you do it. Oh, that makes sense. So we have a type constructor, data constructor, and types wrapped. So here we don't need this. Or better yet, let's just use an ID. For now, let's not worry about those. No. Okay, this is more or less what we're looking for. And this is just a terminator. Let's just make it compile. Except this is not exactly what we want. This should be possible. Okay. This will produce the representation. I wanted the T to be replaced. With the respective value. Let's ask ChatGPT. Oh. Now it should be easier. Okay. And here. Of course. It looks like it got reversed. Oh. We don't need to use right fold. That is better. Yes, of course, the constructor looks better. That is that way, the data constructor. Okay, we can work with this. So let's look at the time. Oh wow, that's a pretty long session for such a simple thing. However, I did have fun. Okay, so I think we've achieved what I wanted to achieve today, just to provide a simple list type or list-based type for a diagram. Now the plan for future sessions is going to be to figure out how to stack all those skewer blocks together and eventually how to implement insertions. But we can do that when time comes. For now, thank you very much for your attention. Have a great Monday and a great week ahead. Yeah, I'll see you next one.